Excuse me, I'll wait. I want to be rude. We ready now? Alright, you need to be on the part. It says exponential day 2 on the bottom, because that's where your first homework problem was. You see a lot of people not grading papers. That means a lot of people didn't do it. So you should be grading the person to your right, because you have some to the left. Anyway, it was 3, example 3E was the first one you had to do. So there's 3 parts to that one. So the first one, or 4 parts actually, the first one after 3 years was $10,870.01. After 12 years was $2,517.68. After 25 years was $304.40. And after 100 years was actually 0. It was .002, but the 2 doesn't round up when you're dealing with money. So there's really nothing left after that. If I need to repeat any of those.
What was the 3 and 12 year?
3 was $10,870.01. And 12 was $2,517.68. Has to be exact, yes. Alright, so on the next page, there's a lot of questions or a lot of problems in that first one where it says example 4. And there's a lot of them in that one, so you're going to have to listen carefully. So on the problem that says f of x equals 60 times 1.62 to the x, all we had to do is write growth or decay. That is a growth problem. So I'm going to kind of go around in a circle clockwise. So the f of x equals 60 times 1.62 to the x is a growth problem. The next one, f of x equals 13 times 0.92 to the x is a decay. Going clockwise, y equals 3 times 6.2 to the x is a growth. The next one, y equals 9 times 15.2 to the x is a growth. The next one, y equals 0.02 times 1.25 to the x is a growth. Going up, f of t equals 250,000 times 0.46 to the x is a decay. Above that one, a equals 0.001 to the t is a decay. Above that one, f of t equals 40,000 times 1.035 to the t is a growth. And the one right in the middle, y equals 32 times 2 to the x is a growth. So all you had to write was growth or decay on that one. Now, on the other part of that, if they wrote the rate, I'm going to give you the rate on those. Okay, so on f of x equals, I'm going to go around in the same circle. F of x equals 60 times 1.62x. The rate is 62%. Okay, put that one. The next one, f of x equals 13 times 0.92. The decay is 8%. Y equals 3 times 6.2 to the x. That is a growth. Oh, let's see here. That's a rate of 520%. The next one, y equals 9 times 15.2 to the x. Was a growth, and it's 142%. One at the bottom, y equals 0.02 times 1.25x is a 25%. Above that one, or f of t equals 250,000 times 0.46 to the x is a 54%. Above that one, 0.001t 99.9%. Above that one, f of t equals 40,000 times 1.035 is a 96.5%. And the one right in the middle is a 100%. So they could either have the growth of the decay or they could have the rate, whichever one they put would be 5. Questions on any of those? All right, the bottom one, example 5, there were 2 parts. It says who has more money at withdrawal time, which is going to be James, and that's by $5.02. And example 6, how much is 1 share of stock this year, and that's $22.06. All right, so pass those back to the owners, please. So pass those back to the owners. You should have your own paper there. You are going to have a test on Friday on this, and if you are choosing not to complete your homework, it doesn't look very good for you on the test on Friday, especially since this was just plugging some numbers in the calculator, given an equation. So that's going to be your choice. Everybody has choices. So those of you that completed it, do you have any questions on some that you may have missed? Yeah. Which one? 5. Example 5. All right, so it says James and Tyler each have $500 to invest. James invests his money at 3.8% for 3 years. So if you're dealing with James, we know that formula we're dealing with is A equals P times 1 plus R to the T, right? Okay, so how much did he invest to begin with? $500. All right, so James had $500. And what was his interest rate? 3.8. So what do I put in the calculator? Or what do I put in the formula that I'm going to put in the calculator, I guess? We don't put 3.8. We have to move the decimal 2 places to the left. So what is it? 0.038. A good mind just to give some quiz right here now since nobody's paying attention. And how many years? 3 years. Okay, so put that in your calculator and what do you get for James? How much did he have after 3 years? Hey, put your Chromebook up. Anybody have an answer yet? Got your calculator, Miss LaQuire? What'd you say, Shelby? 559.2. You sure it rounds to 0.2? What's the decimals there? 0.193, right? So that on money, anytime you have money, you go to 2 decimals. Well, that 3 doesn't round that 9 up, so it's just 0.19, okay? So that's how much James had. Now, then you get to Tyler. How much did he invest to begin with? $500. What was his rate? His interest rate? How much? 4.2%. So what are we going to put in the equation here? 0.042. And how many years? 2.5 years, right? 2.5. Okay, so put that in the calculator. 554.17, 165, and the 5 makes the 6 round up. So we first question, who has more money? Which is going to be James. And then it says by how much, so you subtract 559.19 minus 554.17, and that's where the 502 comes from. So James has more, and he has $5.02 more. So even though they started out with the same amount, Tyler got the higher interest rate, but he did it for a shorter amount of time. So, anybody else? Okay, then. Take us a little quiz. So go on over to the page. You're going to skip the page that has the multiple choice. You're going to skip that part. I actually just copied the problems on your own page. And you're going to go over to the next part that says Exponentials Day 2, Compound Interest and Growth and Decay. You're going to do the very first two problems, 1 and 2. You need a separate sheet of paper. This is a quiz, a separate sheet of paper. You're going to write your equation out on the paper. Where have you been till then? Come on, there we go. So on the quiz, it says, in example 1, a population of 16,000 ladybugs released over a forest region. The ladybugs increase in number by 3% per year. How long will it take for there to be 1 million ladybugs? Wait a minute, I'm not reading the right one, sorry. Whoops. Y'all didn't recognize those problems, did you? Sorry, my fault. Population of bunnies, my fault. So that's my fault. I was working ahead while y'all were doing your quiz and I forgot. A population of bunnies in Australia. That sounds more familiar, doesn't it?
A little bit.
250,000 in 1980. It increases by 3.2% per year. How many bunnies were there? Let's see. How many bunnies were there in 2002? All right. So on that equation, let's see. Number 1. What was the starting amount of the bunnies? How many bunnies did we start with? 250,000, right? Okay, so 250,000. All right, is this a growth or a decay? Growth, because the bunnies are populating, so it's a growth. All right, what was the interest, not the interest rate, the rate of increase? It was 3.2%, but when we put it in the calculator, it's 0.032, right? So we move the decimal. And then how many years? How do you find 22? 2002 minus 1980. So 22. So to the 22 years. So when you put that in there, you should get, and I'm not going to count off if you were, pretty close to this, you should get somewhere around 499,911 bunnies. Somewhere around in there. Okay? Questions on that one? All right, number 2, same thing. In 2005, there were 550,000 bunnies in Australia, but due to disease, the population began to drop by 0.5% per year. How many bunnies are there in 2009? So how many did we start with this time?
550,000.
550,000. And growth or decay? Decay, because they're dying. So minus, now here's the trick, bless you, 0.5%. But what did we put in the calculator? 0.005. Had to be careful on that one, 0.005. And how many years? 4. 2009 minus 2005. I actually did not write the answer down for this one. So let me do it also. 550,000. Whoops, 20 zeros. All right, 50. Yeah. 550,000. Okay, now I got it right. Times minus 0.005 raised to the 4th power. And write this answer down. Okay, so you get approximately 539,082 bunnies.
Is it okay if we put like after the decimal
You mean like put decimals on there? That's okay for now. But think about, you have a part of a bunny.
No, you can't, right?
But just kind of, be careful there.
It's debatable. I can go catch you a part of bunny off. Bunny.
Yeah, but it won't be a live bunny. Alright, so no, I will not count off if you put the decimals on there. Alright, so any questions on those two? Those should have been easy problems. I mean, the hardest part was they didn't come right out and give you the time, but you just had to subtract the years. And then number 2 had a little bit of hiccup in there if you used, instead of .005, if you did .05. But those are the types of things they're going to give you on that EOC. If you can do those problems, and you're great on these, there's about, I think it's 15% of your EOC is exponential problems. So, I mean, it's a good percent, and it's pretty good on it. All right, so we're going to go ahead and start working on some more, and then you'll have more for homework. So, and I will be taking up the homework, so you'll need to do those on a separate sheet of paper, okay? But for now, what we're going to do, you can write them in your notes if you want to, or you can do them right on that packet. All right, so number 3, the value of an antique car can be calculated by. So this is number 3. And they give us this equation. F of x equals 36,500 times 1.025 to the x. All right, now, a lot of times on that EOC there, why do you not have your notes out taking notes? Why do I have to say that every day? On the EOC, they'll give you an equation like this, and they want you to interpret part of it, which is what this A, B, C, D, and E are about. Not necessarily D, because it's just a graph. But they're going to give you the equation and say, okay, what does this mean? What does this mean? What does this mean? And you have to know this is the principal amount. You've got to know this is the rate, whether it's an increase or decrease, and going for the time. So it's just a matter of, do you know how to interpret that problem? So on A, it says write the equation in the form. So A just says write it in this form. So really what they're wanting you to do is they want to know, do you know if it's a growth or a decay, and can you tell me what the rate is? That's what they're really asking. So on this equation, we're going to put f of x equals the principal amount. And we did one like this yesterday. But this time, we've got to take this 1.025 and put it in this form. Now, if you don't know what the rate is, you could actually set 1.025 equals 1 plus r, and you could solve for r. Well, that's just subtracting 1, right? So that leaves me with 0.025 equals r, but we got to make it a percent. So before, when we put it in the equation, we moved the decimal 2 places to the left. This time we're moving it 2 places to the right. So we're multiplying by 100, which is going to give us 2.5% would be our rate. But this is what goes actually in that formula. So 1 plus 0.025 raised to the t power, because we don't know how much our time was. So that would be A. What they really are trying to ask here is, do you know that that's a growth formula? And you should, because it's more than 1. Anything more than 1 is a growth. Anything less than 1 is a decay. And can you take that rate out? That's what they're trying to get you to do. All right, so B, explain the meaning of the R value, which is the rate, using the units of the problem. So who can explain in a sentence what that means? 0.025. Who can give me one sentence that tells me what that means? Please say it. We're talking about an antique car.
The value of the antique car went up 0.2%, 0.25%, 2.5%.
Okay, so, all right, so Hannah says the antique, I'm going to kind of paraphrase, the antique car increases, you said goes up, but increases by 2.5% per year, or each year. That's how it's going to look on that EOC. They're going to give you a sentence like that. And then, of course, it's going to be multiple choice, but it's going to say something like the antique car increases. You know, you have 4 of them. The antique car decreases. So they'll change the increases and decreases, and they'll change the rate over here. So those would be the types of problems they're going to give you and the types of answers. They want to know, do you know it's an increase or decrease? And do you know how to go from that 0.025 to the 2.5? Don't write these down, but this would be the other options they would give you. The antique car, I mean, you can if you want to, increases by 0.025% per year. Or so look at these answer choices. This would be a perfect EOC problem, and those would be the 4 types of answer choices they would give you. So they would say, okay, the antique car increases by this much, or the value of an antique car is modeled by that top equation. Which one of these answers models the rate, the R? They won't say the rate, they'll say the R. And you're going to have to choose between one of those 4. So if you notice, they'll say increases and increases, decreases and decreases. So if you at least know that it increases, because it's more than one, you've marked out 2 answers. And from there, going to say, okay, do you know how to change that back into 8%? That's going to be the second part of it. So that's an excellent example of an EOC question right here with those answers. But anyway, all right, C, explain the meaning of the p-value. Using the units of the problem. So who can explain in a sentence? No, I see your hand raised. The p-value.
The antique car cost $36,500 to start.
Whoops, I forgot antique. The antique car, what'd you say?
Cost $36,500 to start.
Okay, so they're going to rate, let's see, their answer is going to say something like the antique car's value was initially $36,500. That's what you said was perfectly fine. That's how it's going to be worded. Say what you said again one more time so everybody can hear it.
The antique car costs $36,500 to start.
Does everybody understand that? The antique car costs $36,500 at the start. Perfectly fine. But the way they'll have it worded will look something like this. The antique car's value was initially $36,500. It's just a matter of verbiage. I just want to make sure that you understand those are the same things. Okay? All right. D we're not going to do because that's just a graph. We can all graph. E, how much will the car be worth? This was one of the samples like you did on your homework last night. In 3 years and in 12 years. Well, if we have our equation, what are we looking for? We're just looking for a value, correct? I don't know, whatever you're doing, he's watching, so it must be interesting. So we're looking for a car's value. So we're plugging in 3 to be X, and we're plugging in 12 to be X. So on your calculator, mine's not pulled up right now, it'll take it just a minute. Where is it? Let me get pulled up here. Remember, you're talking about money, so you're only going to 2 decimal places. So go ahead and try those yourself. Don't wait for me to write the answer up here. Try them yourself. You got to practice. So it said the antique car, $36,500. You know our rate is 1.025%. 0.025, and we want to know the value in 3 years. So that's how much it's worth in 3 years. Anybody else get that? Now, let's practice this. Remember I said money. What's that decimal going to be? Only 2 decimals on money, so that's not going to be 50 cents. It's going to be 51 cents. So you're going to have $39,306.51.
I got 38,768.06.
What you got right here?
Oh, I got that.
And then we're going to do the same thing. Here's a trick. Instead of having to type all that in, you can hit second enter, and it puts back the same equation you just had. So all I'm going to do is go over, and instead of 3, I'm going to put 12, because we want to know in 12 years. And you can type the whole equation again, but if you hit second enter, it puts back what you have. Why don't you have your calculator out and doing it? Make sure you're writing it down. Everybody else should have their calculator out, doing the same thing we're doing, writing it down. So what are we getting in 12 years? That's what I got. Let me write this one down. $49,088 and how many cents? 44 cents. Okay. Questions on that one? Questions on these sentences, explaining these things? Is anybody still having trouble with that? Explaining or writing a sentence talking about the initial amount, whatever we're talking about, or the rate, or finding the time, anything like that. So we're good there? Okay, so now look at the top of that next page, number 4. Give me just a minute and let me write all of these down, because it's very important that you know how to do these. These are great test questions that you'll find on that EOC, and I want to make sure you understand how to do these. While you're waiting on me to write these down, see if you can match these up. What they want you to do is match up the equation to the rate. So see if you can match those up while I'm writing these down. So you got all these up here, and what they're wanting to know is which equation goes with each rate. This rate on the right side would be given to you in the problem. Which one does it match over here? So that's what they're asking you. The first thing you need to know is if it's an increase, what's going to be in these parentheses? Something that is what? Above 1. Something that's greater than 1. That's your first clue. Okay, so an increase, the parentheses are going to be greater than 1. So that's your first hint. So then if it's a decrease, the parentheses are going to be less than 1. It's going to be between 0 and 1. So it's going to be less than 1. And So that's your first thought. You had a question?
Yes, is it the same thing as growth and decay?
Yeah, growth is an increase, decay is a decrease, yeah. Did right here what Reed asked? The increase is the growth, the decrease is the decay. Same thing. All right, now, the next part. Remember in all these parentheses, that formula was A equals P times 1 is either plus R or minus R, right? Okay, so we could take every one of these parentheses and set them equal to either 1 plus R or 1 minus R. If we knew it was greater than 1, I could say 1.032. I know that's greater than 1, so I set that equal to 1 plus R. Subtract 1, and what do I get? Do what? 0.032. So this would be 0.032. That would be if you're writing this down and paying attention. 0.032. And I'm so sorry if I'm boring some of you. Y'all welcome to go out in the hall, go down to the office and tell them how much I'm boring you, that you're too bored that you can't even take notes. You can sit there and do nothing. So that's 0.032, but that's still not the rate. What do we have to do to that number next? Got to move the decimal 2 places to the right. We're multiplying by 100. So if I move it 2 places to the right, that's 3.2%, right? So we know that that top one is an increase because it's more than 1. And now we know it's a 3.2% increase. So this one is E. Alright, so let's look at the next one. If I take, is that an increase or a decrease? 1.068. Increase or decrease? Is it bigger than 1 or less than 1? 1.068 is a decrease? That's an increase, right? It's an increase. That's larger than 1, isn't it? So it's an increase. So if I take that 1, what? Yeah, 1.068. Same thing that's in the problem, isn't it? Yeah, 1.068. Okay, so this is an increase. Well, if I subtract 1, that just leaves me with 0.068, right? All right, move my decimal 2 places, and what does that give me? 6.8% increase. So that one's F. Okay, on an EOC problem, they're going to give you one of these equations, and they're going to give you these types of answers. They're going to say, okay, which one's an increase, a decrease, and what's the percent? So let's do all the increases first. So we know this one's an increase, right? It's greater than 1. Right, if I take the 1 away, I got 0.68. Well, if I move my decimal 2 places, what does that give me? A 68% increase. Right here, C. Right, now, the decreases are a little bit more complicated, but not major. You're still going to take, instead of the 1 plus R, we're going to deal with the 1 minus R, right? Let me just put it, running out of room here. 1 minus R. So I'm going to take that 0.932, so 1 minus R equals 0.932. Now look at this. Normally we would subtract 1, and we got a negative right there, and we divide by a negative, but just think about it this way. If I move this 0.932 over, it's positive on this side, so when I move it over, it's going to be negative, right? If that R is negative, if I move it over, it's going to be positive, right? So what I'm going to do is just switch these two. I'm going to say 1 minus 0.932 equals R. Well, what's 1 minus 0.932? So 1 minus 0.932 is 0.068. Right, well, if I've got if that's 0.068, now what do I have to do? Move my decimal 2 places. So when I move it over, now I'm at a 6.8% decrease. So 6.8% decrease right there. So A. All right, next one, 0.68. So increase or decrease? decrease. It's less than 1. So say 1 minus 0.68. So 1 minus 0.68 is going to be 0.32. So 0.32, well, if I move my decimal 2 places, it's 32%, correct? So 30, Johnny, sit up. 32% decrease. 32% decrease. All right, and hopefully the last one we've already got. But if I didn't, Zach, you getting all this? 0.32, so I say 1 minus 0.32. 1 minus 0.32 is 0.68. Move my decimal over. So that's 68%, and it's a decrease, so that's going to be B. Do what? It isn't that hard, but those, you will probably have at least 2 or 3 problems on your EOC like this. Easy problems as long as you understand what's an increase and what's a decrease and how to find that rate. And that's it.
Is this going to be on our test
Friday? Oh, yeah. Yeah, this will be part of your test on Friday, yes. All right, so now, number 5. 5 and 6 are kind of just like what the homework problems that you did before, but we're going to go through and do them just to practice. So on example 5, if my pen will write. There we go. Okay, so example 5, Bill bought a used car for $9,100 in 2002. It decreased in value by 3.6% each year. Candace bought a used car for $8,000 in 2004. It decreased in value by 2.2%. In 2008, they compared the values of their cars. Which was worth more? How much more? It's just like the homework problem that you did last night. So if you didn't know how to do the homework problem last night, do this one. It's just like it. Same concept. Hey! So on number 5, let's see. So Bill, I'm going to use B for Bill. Is everybody okay with that one? All right, so B for Bill. And how much was his principal? How much did he start with? 9,100. Okay, so 9,100. And increase or decrease? Increase. You're welcome to sit over here if you, do you need me or?
I'm just curious.
Okay. All right, so we've got 9,100 and y'all said it was a, what were we doing? Decrease. Well, it says it decreased in value, so it's 1 minus, now that's a 3.6%, so what do we do there? Move that decimal 2 places left, so it's not 3.6, it's 0.036, and how many years? And you got to be careful here, they're trying to trick you. He bought it in 2002, and they're asking about 2008, so how many years has passed? 6, okay. Alright, so show me what that one is. 9,100 times 1 minus 0.036 to the 6th power. Here's what I got. Everybody else get that? Got it? Alright, remember we're talking about money, so what's our decimal? 0.04. Okay, so 7303.04. 7303.04. Alright, now, who's the other person? Candace bought a car. So we'll use C for Candace. How much did she pay for her car? $8,000. And her rate of decay was 2.2. So what's my decimal? 0.022. And how many years did she have hers? 4. Don't assume that it's 6. Do not assume that it's 6, because she bought hers in 2004. So this time the rate is going to be 4, not the rate. The years are going to be 4. Okay? Zach, you awake back there? Yeah? Got a calculator that you're working? So start pressing buttons. Alright, so we're doing 8,000. That's what I got. Did I mess up? Are we okay there? Am I not? Okay, so the first part says whose car was worth more. So whose was worth more? Hers was worth more, right? And it says was worth more by, and then it says by how much. So what are we going to do to those two numbers? Subtract them. So 7318.89 minus 7303.04. In there. $15.85. Okay. Alright, so that was just like the homework problem you did last night. So if you did not understand that one then, are we okay now? Excellent test question. Multiple steps. You gotta do two different decays. And you gotta know to subtract them. You will find something like that on that EOC. So are we good with that? Alright, now, example 6. Not a hard problem, but there's one trick in it. So let's look at it. See if you can figure out what the trick is. It's not hard, as I've kind of tried to highlight it. So example 6, it says at the beginning of a study there's 150 bacteria in a petri dish. The bacteria multiply by binary fission, which means they split in two. Have you talked about this in any of your science classes? Probably not a whole lot. Alright, each hour they double in number. Each hour they double in number. Write the exponential equation representing the situation, and how many bacteria will there be in 2 days after the beginning of the study? So if we were just writing, this is not a, come back to my thing. We've been using this equation so far, 1 plus or minus r to the t. That's the one we've been using a whole lot. But yesterday we were also using this one. Remember when we were talking about the zombie apocalypse? We watched the video of the zombie apocalypse? Okay. Did you watch it last night? Oh. Not good, not good. I was upset. Okay. Anybody else watch it? Any of my other Walking Dead fans in here? Did you watch it?
I went and looked up the comics on who Negan killed. And,
Oh, I don't know if I want to know.
in the comic book,
Who's he killed?
Glenn, the Chinese guy, he takes one swing
No.
at his head.
They said
He
there
goes-
could be a curve away from the comic books.
Yeah.
If they were
But
going
hold-
to
I don't know, I
Daryl
don't
wouldn't even be in it.
Yeah, hopefully.
Yeah,
they'll
Daryl's not
change
even
it.
in the comic book, so.
He was in the comic books. He was actually supposed to be.
See,
dead
I
all
thought
the
it was
time.
Glenn or Maggie too, but Aubrey thinks it's Rick, so I
But
don't know.
also in the comics, Rick's in a coma. This is not happening.
I don't know, maybe he beats him to death and he's in a coma. I don't know. Anybody else? Anybody else want to put bets on this? Who do you say?
How it was going, and someone told me that they thought it was Carl. A lot of people looked it up and said.
Well, he did say at the end of it, though, he did say, what was he say? If they scream,
You can scream, you can cry, you can flinch, but nothing's gonna.
no, he said, if they scream, cut the kid's other eye out and feed it to the dad. And make the dad eat it. Did you hear that?
Yeah. So it
Yeah.
should be Carl.
I was like, ooh. You watch Walking Dead?
No.
Oh,
back,
man.
Back in the day I did, but I haven't
It's, I'm burning up. It is
I think
awesome.
So,
I saw
I
it.
think it's the guy
Many
that's
seasons
on Tell.
behind.
The guy with left over.
Oh, you do?
Like, dropped the RV.
Yeah.
Oh, could be. Okay, all right, we'll stop there, because anyway, back to this one. My whole point was getting you back to this equation, because we talked about this when we were talking about the zombie apocalypse. All right, so how many bacteria did they start with? 150. So the initial population is 150. All right, now, what's our rate? What's B? You have to be looking at the problem now. What is B? Did they give you a rate? Do you see anything in there about a percent? There's no percents anywhere in there, is there? But what's the key word, Noah? Double. Okay? They may give you something like this on your EOC. So instead of giving you a percent, they're going to say, oh, it doubles. Well, what do you think double might be? Remember, this is a 1 plus something, so we're really doubling 1. So double 1 is 2 to the x. Okay, so if they said it triples, then it would be 3 to the x, okay? I just wanted to put that one in there. So if we put that in there, and let's see, how it says something. Each hour they double in time, write the exponential. How many bacteria will there be in 2 days? So x is 2. So 150, and we can do this one in our head. 150, what's 2 squared? 150 times 2 squared. Oh Lord, now we're gonna have to compete with that outside. All right, 2 squared is 4. Right, 4 times 100 is 400. Oh, out here. Johnny, close that window for us, please. Oh, hello. Thank you. All right, so 4 times 100 is 400. 50 times 4 is 200. Yeah.
If they're doubling by the hour, then wouldn't it be more than 2?
Let me, if they're doubling by the,
If they double by the hour.
they
then
double
it's
by the
48
hour.
It'd be 48 hours.
Okay, let me finish this, all right? So what's 150 times 4? 600. Okay, now, finally, somebody is paying attention. Samuel, say what you were going to say again. So let me finish this. We were going to say 600 bacteria. And y'all did not catch this yesterday. I had candy ready to give out. 4 o'clock, called it, and y'all didn't catch it. I'm disappointed. So Samuel, say again what you were going to say.
They double by the hour instead of by the day.
They double by the hour. It asks for 2 days.
48
But if they double by the hour, how much are they going to double in 1 day? 24 times, right? They're doubling every hour. So every day they're doubling 24 times. So if we're doing 2 days, it's not going to be 24, it's going to be 48. Thank you. I'm going to show you where nobody caught it yesterday. We were talking about the mosquitoes. You may remember that problem? We put the mosquitoes in the jar and we fill it full of bleach fumes. Nobody caught that yesterday. It's the same type of problem. Alright, so it's 150 times 2 to the 4th. So now, how many, be honest, I'm going to say out of 28, 27 of you didn't catch it, how many of you would have stuck with that right there? Just about everybody. Guess what? You think that answer is going to be on the EOC? Yeah, it will be. So you've got to be, remember when we started this yesterday and I wrote up here, be careful of your units. They will try to trick you on the units. Did you say it, Reed? Oh, okay. Be careful. This will be on the EOC, I promise you. They will try to trick you. Is it fair? No. Are they going to do it? Yes. All right, so 150 times, now I can't do this one in my head. 150 times 2 raised to the 20, whoops, not 24, 48 power. Ooh. How many bacteria is that? That is a really big number. That means move that decimal 16 times, right? So if we move it here, 1, 2, 3, 4, 5, 6, 7, 8, 9, we've still got 7 more zeros to add out here. It's a pretty big number, isn't it? Remember we were talking about viruses yesterday? What were some of the factors, and y'all named some of these, what were some of the factors that could affect population growth or population decay? If you have a virus, think about that virus that infects all the people, and when they die, they become zombies. If in 2 days we went from, what was it, 150 bacteria to, I don't even know what kind of number that is. It's bigger than like a trillion or whatever. I don't even know what that is. In 2 days, that's how fast it spreads.
There's 8 commas the next one. It's a lot.
8 commas, so you wrote it out, so I mean that's a lot. So that somebody said diseases yesterday, didn't they? I don't know who said it, but somebody said diseases, in fact. Okay, so anyway, here's where we're coming up. All right, I got to get to this one last problem before we go because we have not done one like this before. In all of these problems, we have been solving for the, not the initial, the final amount. So turn over to where it says example 3. This was the one where I was reading and y'all freaked out on me because you thought that was your quiz. It says a population of 16,000 ladybugs. Everybody see where we are? Okay, example 3. All right, so let's see. A population of, well, let me read it out first. A population of 16,000 ladybugs is released over a forest region. The ladybugs increase in number by 3% each year. Get in the habit. Underline that important information. I know that's a test-taking strategy that you have been told since like 4th grade, at least 3rd grade, I hope. All right, 16,000 ladybugs increase in number by 3% per year. How long will it take for there to be 1 million ladybugs? Show and sketch that justifies your response. I'm not so concerned with that one. Everybody found it? You got it? Okay, so what's the initial amount? 16,000 ladybugs, right? So 16,000. Are they increasing or decreasing? Increasing. At what rate? 3%. So 0.03. So 1 plus 0.03. They didn't tell us the time, but they did tell us the final amount, didn't they? What do we want? Well, not silly that we want 1 million ladybugs, but they told us how long, or asked us how long will it take for us to get to 1 million ladybugs. If you're like me at my house, you don't want ladybugs because they crawl all over the place and get up in the lights. You know what I'm talking about? You find ladybugs everywhere.
Yep.
All right, now, we didn't do one like this yesterday. This is the first time. We're solving for, that's objective looking T, isn't it? Fix that. We're solving for T. And this is different, new concept. So, we got to get T by itself, but T is the exponent, correct? Yes, T is the exponent. All right. So, this 16,000 is being multiplied. Opposite of multiplying? Dividing. All right, so divide by 16,000 on both sides. So those cancel, and then we've got 1 million. I think I put too many zeros in there. Hello? Okay, thank you. Bye-bye. Destiny and Chandler, you're going to go drive. 1, 2, 3. You need to make sure you get this example, because this will be what your homework will be on, okay? All right, so 1 million divided by 16,000. Is that what y'all got? Yeah, you got calculators, right? 62.5? All right, so 62.5. Now, here comes the new part. I'm going to go ahead and say 1 plus 0.03 is 1.03. Is everybody okay with that? Okay, now, here's the new part. New button on the calculator. Go to your calculator. And these are, does anybody know what our decimal system is based on? Right, it's on a base 10 system. Remember back in, I think it's 4th grade when I taught this, the gallon man? Everybody remember the gallon man, and you did the quarts and liters and all that, and the metric part. But then you had where you were going from, you started at meters, and you went to millimeters and centimeters and decameters, or remember that thing? Or you're doing liters or whatever. Our decimal system, or our number system, is based on a base 10 system. So we're going to start using this button right here, LOG. It's called logarithm. Everybody find that button right now, because you've got to know it. So find the log button, right beside 7. Everybody found it? All right, let me come back to here. So, in order to get rid of, we'll throw you a little bit of, yes, about 5 minutes left when I get through this problem again. In order to bring this exponent down in front, got to do this. And if you really want to know the math behind it, I'll be happy to stay there and break and explain it to you. I got a feeling nobody's going to ask me to stay back and explain this, okay? But here's what you do. When you're looking for the exponent, you're going to take the log of both sides. So you're going to say log of 62.5. You're just going to write log in front of it. And we're going to press that button. And here's the trick. Pay attention, Reed, pay attention. See this T? That exponent's going to come down in front, and you're going to say log of whatever's in parentheses here, 1.03. Now the T's down in front, and what's happening to the T and the log 1.03? What are they doing? They're being, starts with an M, multiply. So the opposite of multiplying, dividing. So we're going to say log of 1.03. divided by log of 1.03. Those will cancel. Now you can pick up your calculators. But please, 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 please pay attention to what I'm about to do. When you hit the log button, what does it put right out by it? Well, I hit it. Notice what it puts. It puts log and then puts a parentheses. So we're going to say log of 62.5. Key point. You must close the parentheses. Because we've got to divide. So you got to tell the calculator, hey dummy, this is my numerator. So So you're saying, all right, this is the numerator, log 62.5 divided by log of 1.03. Not so important that you close it here. Doesn't matter if you do or you don't. You must close it here. If you don't, you will get the wrong answer. And the bad part about this is, you will never know you got the wrong answer. Because the calculator's not going to come up with a big error. Danger, danger, you didn't close the numerator up. It's just going to give you a number, and you're going to be like, yeah, I got the number. Guess what? Is it going to be one of those answers on there? Yeah, it will. Hit enter. You're not going? Okay, well, good. Here's my answer. 139 point, now we're talking about years, aren't we? 139, yeah, how long will it take? So in 139.90 years. Remember, we're dealing with units, word problems. 139 years. So to go from 16,000 to 1 million ladybugs at a population growth of 3%, 139, 140 years. I don't think I'll be around to see a million ladybugs, which is good. Anybody not get this number? Notice what happens when I go back to my calculator. If I say log of 62.5, I don't close the parentheses, and now I put log 1.03. Did it give me a number? Yeah, it gave me a number. Is that the correct number? No, that is not the correct number. But you will never know it, because it's not going to come up with an error. You've got to remember 62.5. You've got to remember to put the parentheses at the end of it. Okay? All right, now, on this paper, you've got, we got mosquitoes. Yes?
So it doesn't matter if we close the second one?
No, it doesn't matter about the second one.
So can we close it?
You can close it. It'll still give you 139.9. Why did they call y'all up there if they're not driving?
He doesn't want to get Bailey out of the same class every day, so he's going to wait till the
Okay, all right. Anyway, so did everybody hear what Slade and Reed asked? Does it matter if we close the last parentheses? No. Can you? Yes. Doesn't matter. Kind of like multiplying by 1. Do you have to write times 1? No. Does it matter? No. Can you? Yes. Same thing. All right, so for your homework, you are going to do that second example 2. Everybody ready? All right, so you got example 2. You've got example 3. Notice there's 4 parts to example 3. Don't worry about the brief sketch. We're not going to do the sketch again. Over there. And then you've got, basically you're finishing this page. I'm just making sure you're aware that there's different parts on each one. So you've really got 1, 2, 3, 4, 5, 6, 7, 8, 9 questions there. So you're finishing this page. Tomorrow, instead of taking a homework quiz, I will take this up for a homework grade. So this needs to be on what, Reed? Another sheet of paper, okay? I will be here after school if you need help for a little bit. On my video walks.